Hello, everyone. My name is Dominic Harding. As some of you may know, microplastics are some of the most prevalent objects all over the world. What you may not know are the smaller, more prevalent, and more harmful cousins of microplastics called forever chemicals. Forever chemicals, officially dubbed PFAS, which are perfluoroalkyl and polyfluoroalkyl substances, are a group of man-made chemicals known for their strong carbon-fluorine bonds and the amount of said bond that they have. This bond is one of, if not the strongest in chemistry, which means once these chemicals are formed, the degradation and half-life are very slow, almost 1,000 years slow, naturally or with human intervention. That is why they've started to be called forever chemicals. Because of this durability, they are everywhere. They stick around in the environment and can even build up in our bodies over time. And yeah, when I say everywhere, I mean everywhere. We're talking about all forms of water, even down to the Mariana Trench. Soil, even as remote as parts of the Amazon River. Air, all the way in Antarctica. And even in the bloodstreams of most animals on Earth, including humans. Studies have found them in nearly every person tested. This is something microplastics still don't have the concentration to do. Multiple studies show that these chemicals aren't just circulating our bodies, they're causing harm. Research has linked forever chemical exposure to weakened immune system responses, especially in young kids. One study even connected it to reduced vaccine effectiveness and higher infection rates. On top of that, forever chemicals have been linked to health issues such as high blood pressure, certain cancers, and even hormone disruption. And it's not just people being affected, the environment and ecosystems might have it much worse. These chemicals pollute water supplies and even build up in wildlife. And the worst part is that most of these forever chemicals, largely newer ones, haven't even been fully tested for toxicity yet. That's why researchers are urgently rallying for stricter regulation, more toxicity testing, and more public awareness. It is important to note that in all of this, forever chemicals are actually very useful. They have been used in everything from nonstick cookware and stain-resistant clothing to firefighting foam. In the military, they're used in equipment and technology that is needed to withstand in extreme conditions. In medicine, they've been used to make anesthesia, joint replacements, and personal protective equipment much more effective. So sadly, they are not all bad. These chemicals have brought some advantages to modern life, and because of that, a full sweeping ban on forever chemicals could cripple both production jobs and the jobs that use these equipments. But the question is, how do we deal with them now? Scientists have been researching ways to break them down, and some of the new techniques are getting very promising results. One approach uses electricity and argon gas to zap the chemicals apart in water. One approach uses high-frequency microscopic sound waves and pressure to produce the heat to pull the fluorine atoms off of the compounds. There's even research into genetically engineering fungi that might naturally digest these compounds. And most recently, a groundbreaking discovery showed that under the right conditions, even some forever chemicals can actually degrade on the surface of microscopic water droplets. Sadly, not at the rate needed to reduce concentrations as a standalone option. To sum it all up, forever chemicals are toxic, long-lasting, and everywhere. They are disrupting many parts of many natural functions and destroying natural ecosystems. But sadly, they are also really useful today in medicine and defense. Scientists and researchers are lobbying for stronger regulations, raising awareness, and working on ways to safely break them down. It is a daunting task, especially with new forever chemicals popping up all over different markets. But the options being researched are making it even more possible. Thank you very much for your time.